Good day, students. Today we're going to look at solving logarithmic equations. This is a second video in solving equations. These come from number 5 on page 136 in practice 2. That's book 2, chapter 5 in 1026. Now, you'll notice in these three equations that I have here, there's a pattern different from the pattern in the first video, right? You can see here I have logs on one side, right, and a number on the other side. Okay? Logs on the left-hand side, number on the right-hand side. Logs on the left-hand side, number on the right-hand side. And that requires a little bit different solving than the last type, which had logs on both sides of the equation. So we call these log equal number type solving, okay? Log equals number. So what do we do with these? Well, we're going to have to switch out of logarithmic form into exponential form using a rule that we've used before. Log base b of some value equals an exponent, okay, becomes, of course, the base raised to the exponent equals the value. Now we've used a double arrow here because we interchange back and forth. We go from exponential form to logarithmic form, right? We've done that several times. So when it's log equals a number, okay, we're going to use this. However, one other little condition. Notice that we don't use that unless there's a single log. Single log on the right hand side equals a number or an exponent on the other side. So that's okay for the first example because it's already a single log, right? In B we have a single log. However, for E, what do you notice? Two logs. So we're going to have to make that a single log first before we switch to exponential form. Same thing down here. Look at this one. We have two logs here. So we're going to have to make it a single log first before we can solve, okay? Or before we can switch to exponential form. Alright, let's start. First one, B here, is already a single log equals to a number. So I'll use a square arrow here, show you I'm switching now from log form to exponential form. Identify the base. Of course, the base here is x, right? So x raised to the exponent. What's the exponent? It's a number over here by itself, which is 2, equals the value of the expression, which in this case is 36. So we just switched from log form to exponential form. Now the problem can be solved. Okay, fairly straightforward. You can see right now, therefore, x is equal to the square root of 36. So x is equal to 6. So the first one, pretty straightforward. The next one, we have two logs. So therefore, I cannot switch yet. Cannot switch to exponential form yet. I'll examine this. I'm going to look closely at the coefficients, make sure I have, because we have to apply the power rule of logs first. If there's coefficients in the front other than 1, we must move them. Okay, no, I don't have any here, only have 1. So right away I can bring these two together as a single log, okay, by multiplying them. Now why did I pick multiplying? Pick multiplying because I'm adding. And when you're adding under separate logs, that's the same as multiplication under one log. So this is 9 times x minus 3 equals the 3 on the other side. Now I'm going to take it one step further. I'm going to multiply the 9, distributive property. I think you see it there. So that would be 9 times x is 9x minus 3 times 9, 27 equals 3. Now you can't solve a log equation with the word log in it. It must come out somehow. Now with the last type with logs on both sides, we dropped them. But on this type, with logs equals a number, we must switch, just like we did in the first question. Now remember, it's base raised to exponent equals the value of the expression, right? So you don't use v, that's the letter I use. Lots of teachers use different letters, but identify the base. Now, what's the base? The base, of course, is 2. Identify the exponent. That's right, the exponent is 3. And put your equal sign there, and then the rest of the expression must be the value. So there it is. Now you're down to solving a linear equation. We know that 2 cubed becomes 8 equals 9x minus 27. So if I add 27 to both sides of the equation, right, which has the same effect as moving it across and changing the sign, I get 8 plus 27 equals 9x. 8 plus 27, that's 35. And now, of course, we can isolate x by dividing each side by 9. Therefore, x is equal to 35 over 9. So not too bad. Alright, let's have a look at the last one here. And the last one has, again, 2 logs, so I cannot switch yet, cannot switch to exponential form yet. You can only switch when it's a single log. Okay, so how do we work that? Well, again, watch what I'm doing. See that? What am I doing? That's checking for any coefficients that might have to be moved up as exponents. Called the power rule of logs, right? Alright, let's get rid of that. There's none there to move. Now, I can bring these two together as one single log by using what? Well, when it's subtraction, it becomes a quotient or division, right? So it's 2x plus 4 divided by x minus 1 equals 3. Now I have a single log, don't I? Now, look, I have a single log on the left-hand side, right, with a number on the right-hand side. Now I can switch. And again, I'll use this square arrow to show you I'm switching out of log form. Okay, identify the base. What's the base? Base is 2. Identify the exponent. Exponent is 3. Equals the remainder of that, which of course I call the value. Now simplify. 2 cubed, that's 8. And that's considered to be over 1. Now why did I put that over to 1? Because I can see equal to a fraction, I'm going to cross multiply to solve. Right? So now we're going to cross multiply. We're going to get, let's just move up here. We're going to get 8 outside of x minus 1 equals 1 times 2x plus 4. So I get, and the distributive property gives me 8x subtract 8, right? So it's 8 times x equals 2x plus 4. Now, I'm going to do a double switch here. I'm going to bring the 2x to this side, which means subtract 2x from both sides. At the same time, I'm going to bring the negative 8 to this side, which means add 8 to both sides. So this will now give me 8x subtract 2x equals 4 plus 8. So 8x subtracts 2x, of course, is 6x. 4 plus 8 is 12. Dividing both sides by 6, we end up with x equals 2 as a final answer here. Okay? So there's examples of 3 different examples of solving log equations in the form of logs on one side equal to a number. That's on page 136.